Now, how to find the resistance of the wire? How the resistance is dependent on length, area and resistivity. Internal resistance is denoted by small r. The external resistance is connected externally to the circuit, which is generally denoted by capital R. In the place of I3, we need to substitute minus 2 divided by 17, which is equal to 2. Hello everyone, welcome to session 6 of chapter 3 Current Electricity. This is Swati from Department of Physics, Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. Dear children, till last session we have studied all the theory concepts regarding current electricity. And in today's session, we are solving few numericals based on the concepts which we are already thorough with. Let's start with the first problem. 100 milligram mass of nichrome metal is drawn into a wire of area of cross section 0.05 millimeter square. Calculate the resistance of the wire given that the density of the nichrome is 8.4 into 10 power 3 kg per meter cube and resistivity of the material is 1.2 micro ohm meter. Here the nichrome metal is drawn into a wire of area of cross section that is 0.05 millimeter square. We just have to reduce this to meter square and we get the value 0.05 into 10 power minus 6 meter square, because milli is 10 power minus 3. Here we have millimeter square and here the meter square is a unit of area. So the mass of the wire is given as 100 milligrams. So let us write this in kg, that is we get 100 into 10 power minus 6 kg, because milli is 10 power minus 3 and converting grams into kg, it is again 10 power minus 3. So we get 10 power minus 6 kg. Now we have to calculate what? We have to calculate the resistance of the wire, R we have to calculate, and it is also given that the density of the nichrome is 8.4 into 10 power 3 kg per meter cube. The resistivity of the material is also given. Resistivity of material is denoted by rho, which is 1.2 into 10 power minus 6 ohm meter. Now, how to find the resistance of the wire? How the resistance is dependent on length, area and resistivity. We have a formula to find R, that is rho L divided by A. In this we have values of rho and A, but we do not know what is the length of the wire. We can calculate the length of the wire with the help of given data. So we have mass, we have density. So we know what is the formula for density. It is mass per unit volume. And from this we can calculate volume, which is equal to mass divided by density. With the help of volume, we can find length because we already have area. We know that volume is equal to area into length, but we need length to calculate R. So from this we can write length is equal to volume divided by area. So let us now find out the volume with the help of this formula. So what's the formula for volume? It is mass divided by density. What is mass? It is 100 into 10 power minus 6 and density is 8400 kg. It is 8.4 into 10 power 3, which is nothing but 8400. Solving this, we will get 12 into 10 power minus 9 meter cube. So this is our volume. Now we got volume. Let us find out length value. So what's the formula? L is equal to 12 into 10 power minus 9 divided by area. Area is 0.05 into 10 power minus 6. So we get the value of length as 240 into 10 power minus 3, or it is 0.24 meter. So this is our length. Now we know the value of length. We know what is the area. We know what is the resistivity of the material of wire. We can calculate the resistance. That is R is equal to, the rho value is 1.2 into 10 power minus 6 and length value is 0.24. What is area? Area is 0.05 into 10 power minus 6. So solving this, we get R is equal to 5.76 ohms. Since it is resistance, we are calculating the SI unit of resistance is ohm. So this is how you need to make use of the data to get the desired answer. So let's move on to the next problem. Our next problem is a wire having length 2 meter and diameter it is 1 millimeter and resistivity of the wire it is 1.963 into 10 power minus 8 ohm meter is connected in series with a battery of EMF 3 volt and internal resistance 1 ohm. Internal resistance is denoted by small r. The external resistance is connected externally to the circuit which is generally denoted by capital R. So here we have to calculate the resistance of the wire that is capital R and the current in the circuit. Current is denoted by I. And what is the formula to find out the resistance? Again it is R is equal to rho L divided by A. But A value is not directly given. It is given the diameter. So the diameter is 1 millimeter here which is 1 into 10 power minus 3 meter. It is not radius given. You can convert this diameter into radius and substitute in the formula of area, or you can directly do it as R is equal to rho L divided by pi d square divided by 4 because pi d square by 4 because we are not representing this in terms of radius. We know radius R is equal to d divided by 2 and R square is d square divided by 4. Now we can write it as 4, this 4 will multiply to the numerator and 4 rho L divided by pi d square. Let us now substitute all the values what we have, that is R is equal to 4 into rho value is 1.963 into 10 power minus 8. The length of the wire is 2 meter divided by pi value is 3.14 and d value is, we know it is 1 into 10 power minus 3 the whole square, since it is d square. And now simplifying this, we get the resistance of the wire R is equal to 5 into 10 power minus 2 ohms. Here it is 10 power minus 3 into 2, then it is 10 power minus 6. When that goes to numerator, it becomes plus 6. So minus 8 plus 6 is equal to minus 2. So R is equal to 5 into 10 power minus 2 ohms. Our task is not just to find the resistance of the wire, we have to find the current as well. So what's the formula to find the current? We have internal resistance, we have EMF of a cell, we do have the resistance of the wire. So the formula to find the current in a circuit is E divided by R plus R. Now what's the value of E? It is 3 volt and the resistance what we have calculated, it is 5 into 10 power minus 2 plus the internal resistance is 1. So it can be 3 divided by 5 into 10 power minus 2 is 0.05 plus 1. So it will be 3 divided by 1.05. Solving this we get 2.85 amps. Since we are calculating the current in a circuit, the unit of current is ampere and hence it is 2.85 amps. So let's move on to the next type of problem, that is two identical cells. Here it is given identical cells, which means their properties are same. They have equal EMF and equal internal resistance. They are connected either in series or in parallel combination, gives the same current of 0.5 amperes. They are giving the same current, that is 0.5 amperes, even when they are connected in parallel as well as they are connected in series. And it is connected through an external resistance of 4 ohms, that is capital R is equal to 4 ohms. Find EMF and internal resistance of each cell. So let us now consider the first condition when they are in series. When two cells are in series, we know E equivalent is equal to sum of the EMFs of two cells, that is E1 plus E2. And in the question it is given clearly that they are identical cells. So now I'll take it as ES because equivalent circuit means they are in series combination first we are considering, which is equal to, since they are identical, I'll take it as E and E. So E plus E gives us 2E. Similarly, the internal resistance R equivalent is equal to sum of internal resistances of two cells in series, that is R1 plus R2. Since they are identical in series combination, RS becomes R plus R, which is equal to 2R. Now we have I is equal to E divided by R plus R. Is the expression to find current. What is the value of I? It is 0.5 amperes. So we can write it as 1 divided by 2 because we know 1 by 2 is nothing but 0.5, which is equal to E equivalent is 2E divided by, and the external resistance is 4 plus it is 2R. Now let us cross multiply this and we'll write an equation. 2 into 2E becomes 4E is equal to 4 plus 2R into 1, that is nothing but 4 plus 2R. So dividing this equation by 2, we get 2E is equal to 2 plus R, and this is my equation 1. This is for a series combination. Let us now try this out for parallel combination. Now for parallel combination, what is the formula for equivalent EMF? E equivalence is equal to E1 R2 plus E2 R1 divided by R1 plus R2. And solving this, we get E equivalence is equal to E. Similarly, R equivalence is equal to R divided by 2 for parallel combination, that is when identical cells are connected. Now let us write the same formula for current, that is I is equal to E divided by R plus R. Now our E is E itself and R is 4, and the small r, that's internal resistance, is R divided by 2. So let's take the LCM in the denominator. We get 2 in the denominator as LCM and 2 into 4, 8 plus R in the numerator. We remain with E. So this multiplies with this and we get 2E divided by 8 plus R. And in the LHS we have 1 by 2, which is equal to 2E divided by 8 plus R. Let us now cross multiply these two and we get the equation 4E is equal to 8 plus R. So now this is my equation 2. I have two equations now. One is from series, that is 2E is equal to 2 plus R, and 4E is equal to 8 plus R. Let us consider these two equations and solve for EMF. So I have 2E is equal to 2 plus R and 4E is equal to 8 plus R. So let us subtract equation 1 from equation 2. So what do I get? I get 4 minus 2 is 2E, which is equal to 6, because 8 minus 2 is 6, and EMF will be 6 divided by 2, which is equal to 3 volt. Here we have to find out the EMF and internal resistance. EMF is 3 volt now. Let us find out the internal resistance by substituting the value of E in equation 1. In equation 1, I have 2E, which is equal to 2 plus R. So 2, E value is 3, which is equal to 2 plus R. 2 3s are 6 is equal to 2 plus R, and R is equal to 6 minus 2, which is equal to 4 ohms. So this is the internal resistance and EMF of two identical cells when they are connected in series and parallel, producing a current of 0.5 amperes. Let us now move on to the next important problem, that is to determine the current in each branch of network as shown in the figure. Here this is a Wheatstone network consisting of 4 resistances, and the current is flowing through the entire circuit, and it is maintained with a galvanometer of resistance 5 ohm. And now we have to find out the current in each branch of the network. So now this network consists of 3 loops. One is A, B, D, A. The other one is B, C, D, B. The other one is A, E, C, B, A. So this itself is again an entire loop. So let us apply KCL and KVL to find out the currents in each branch of this network. So let us now apply KVL to this loop A, B, C, E and A. So our direction of observation is going in a cyclic way, and let us now write the equations according to Kirchhoff voltage law. Now this is I1, which is having a resistance of 10 ohms. So here from which I am starting A, B. So I am going along this way, which will get plus 10 I1. Why plus? Because the direction of observation is along the direction of current. A, B, C, E, A. So B along the direction of current only we are going. So it is again plus, here let us say we have 5 ohms of resistance. So 5 into I1 minus I3. Since the loop is going in this way, here the direction we are going from negative of the cell to positive. So we get minus 10 Again, we have 10 ohms and plus I1, I2 in this way, that is from E to A. So, we get plus 10 I1 plus I2. This is the equation. Let us now simplify this. That is 10 I1 plus 5 into I1 is 5 I1 minus 5 into I3 is 5 I3 minus 10 we have already plus 10 into I1 is 10 I1 plus into plus is plus 10 into I2 is 10 I2. Let us now simplify for I1. We have 10 I1 plus 5 I1, that is 15 I1, and we have 10 I1 here, that is 15 plus 10, 25, 25 I1 minus 5 I3 I have here plus 10 I2 I have here minus 10 is equal to 0, or we can write this as 25 I1 plus 10 I2 minus 5 I3 is equal to 10. Now, we can reduce this by dividing this equation from 5. So, we will get 5 I1 plus 2 I2 because 5 2s are 10, 5 5s are 25 and hence it is 5 I1 plus 2 I2 minus I3 is equal to 2 because 5 2s are 10. So, this is my equation 1. So, we are done with the first loop, that is A, B, C, E and A. Now, let us move on to the next loop. So, let us apply KVL to this loop A, B, D and A. So, what do we get for A, B, D, A? Current, it is I1, resistance 10 ohms. So, it is 10 I1, A, B, D, A it is. So, I am considering only this loop now. So, it is 5 I3 because our direction of observation is along the direction of current across the galvanometer. So, it is 5 I3 and now we are going opposite to the direction of current and hence it is minus 5 I2 which is equal to 0. Now, we can reduce this by again dividing from 5. So, we will get 2 I1 plus I3 minus I2 is equal to 0. This is my equation 2. Now, we are done with the first loop and second loop, that is half of our Wheatstone network. We are now remain with this loop, that is B, C, D and B. So, we are applying KVL to B, C, D and B. So, B, C, D, B it is and hence we can write 5 into I1 minus I3. From C to D, it is opposite to the direction of current and hence minus 10 into I2 plus I3. It is B, C, D and B and we are going opposite to the direction of current across galvanometer. So, it is minus 5 I3 is equal to 0. Now, we can just multiply individually and we write 5 I1 minus 5 I3 minus 10 I2 minus into plus is minus 10 I3 minus 5 I3 is equal to 0. Now, let us see how many I3 terms we have. 5 I3 minus 5 I3 minus 10 I3 minus 5 I3. So, minus 5 minus 10 minus 15 minus 15 minus 5 minus 20. So, we get 5 I1 minus 10 I2 minus 20 I3 is equal to 0. Let us now divide the entire equation from 5 and we get I1 minus 2 I2 minus 4 I3 is equal to 0. So, let us say this as equation 3. So, let us now consider equation 1 and equation 3. By adding equation 1 and equation 3, we have an equation 1 that is 5 I1 plus 2 I2 minus I3 is equal to 2. And what is our equation 3? We have got I1 minus 2 I2, I1 minus 2 I2 minus 4 I3 is equal to 0. So, let us now simplify this. This 2 I2 minus 2 I2 gets cancelled and we get 6 I1 minus 5 I3 is equal to 2. This is my equation 4. So, let us now consider equation 2 and equation 3. What is my equation 2? Let's go back to the previous slide. This 2 I1 plus I3, 2I1 plus I3 minus I2 is equal to 0. That's my equation 2. And equation 3 is I1 minus 4I3 minus 2I2 is equal to 0. So let us multiply this equation from 2. So what do we get? 4I1 plus 2I3 minus 2I2 is equal to 0. And here I have I1 minus 4I3 minus 2I2 is equal to 0. Now we have to change the signs and this will get cancelled and we remain with 3I1, 4I1 minus 1I1 is 3I1 plus 6I3 is equal to 0. So this is my equation 5. So let us now consider equation 4 and 5. So equation 4 gives us 6I1 minus 5I3 is equal to 2 and equation 5 is 3I1 plus 6I3 is equal to 0. So now let us multiply this equation by 2. So now we get 6I1 minus 5I3 is equal to 2. 2 3s are 6, 6I1 plus 6 2s are 12. I3 is equal to 0. Now let us simplify this. These two will get cancelled. Minus into minus becomes plus with negative sign. So 12 plus 5 is 17. I3 which is equal to 2 and I3 is equal to minus 2 divided by 17 and the value of I3 becomes minus 0.1176 amperes. Since it is current, it should be ampere. Now let us substitute the value of I3 in equation 4 and we get 6I1 minus 5. In the place of I3 we need to substitute minus 2 divided by 17 which is equal to 2. So let us now simplify this by multiplying minus 5 with the terms which is there in the bracket. So what do we get? 6I1 minus into minus becomes plus 10 by 17 which is equal to 2. And simplifying this, we get the value of I1 which is equal to 0.23 amperes. Now we got the value of I3 and I1. We'll now have to find out the value of I2. For that we have to make use of equation 2. So we have an equation 2 that is 2I1 plus I3 minus I2 is equal to 0. Let us substitute the value of I1 and I3 in the above expression. We get 2 into the value of I1 is 0.23 amperes plus the value of I3 is minus 0.1176 amperes minus I2 is equal to 0. So simplifying this, we get the value of I2 as 0.352 amperes. So this is how you need to find the current throughout the network. That is, we have now calculated the value of I1, I2 and I3 with the help of Kirchhoff voltage law in a Wheatstone network. So please try out few more examples and be thorough with the numericals from the chapter Current Electricity. Since it is a master chapter, it is very important to know about each and every formula. In the next session, let us solve few more numericals related to Wheatstone network. Until then, keep learning all of you. Practice all the problems. See you all in the next session. Thank you.